Hello learners, welcome to today's video. We are going to look at a live case study of predictive modeling using real life examples. I'm Perumal Jaikumar. I've got 20 plus years of corporate experience across risk management and analytics consulting. I've traveled across various locations across the globe and I've done client delivery. First, we'll do a recap in terms of the overall predictive model building process. As we have seen in our previous video, the first and foremost is defining what is your business problem, what is your business objective. So once we know what is our business problem, then we can convert that business problem into a statistical problem. Next is identifying what are all the data elements which we need, and as they say, garbage in, garbage out. So we need to kind of review the data, explore the data, and clean up the data if there are any missing values, if there are any outliers, and so on. So the data preparation and pre-processing plays a very key step, because what data we feed in is what is going to go into the model to get trained. And then we perform exploratory data analysis, where we'll be analyzing the data using various different histograms, graphs, charts, etc. to see the distribution of data and to understand which are our target variables, which are going to be our dependent variables, and so on. Once we have analyzed the data, we can also take a call if you want to create any new variables, if you want to transform the data, create additional variables like log of a particular variable or a square root of a variable, or you can create ratio variables like in mortgage scorecards, we create variables like loan to value ratio and so on. The next important feature is how do you select the features or the variables. Here is where there are various techniques and so on. One very widely used technique is correlation analysis. You can do a correlation between the various independent variables and the target variable, and then that helps us identify which are the variables which are highly correlated with the target variable. In some cases, given we have already got a lot of other independent variables, so we also need to see if two variables are already correlated to each other, so that if we don't want both the variables, you can retain only one of them, or you can keep both of them, because in some cases there will be a lot of incremental value add from an additional variable. So once we have done all the feature selection and so on, now we can determine which model we want to go in. So that's where, if in case it's a continuous variable, target variable, we can use regression, linear regression. If it is a binary variable, then you can use logistic regression. So this is where once you have decided which model you want to go with, then you can train your model, and then is where we'll see a live example where we'll see how we can iteratively fine tune the model based on the output which comes in. Either we can drop some of the variables, add in variables based on the information value which adds it in, and we can also simultaneously evaluate the final model output based on the model evaluation metrics which we looked at, like your classification matrix, your accuracy ratio, precision, recall, and also for regression and logistic regression, we can look at the metrics like the area under the curve and mean squared error and so on. Post we have developed the model, we need to validate the model. That is where when we are training the model, we don't generally run the model on 100% of population. We can run it on like 70% of development data set, and then you can leave some for the validation purpose, and also some of it you can even leave for some out of sample validation as well. So once the model is built, then you go back to your client stakeholders and so on, and kind of get an approval from the business in terms of are they comfortable with the model or do they need any further iterations. So you can run this with your client stakeholders, and make any modifications depending on their business requirements. Once the model is approved, now the model is good to go. Please remember the model has been built on an historical data where we already knew a predictive value in terms of what we are trying to predict. But once the model is built on this particular data, once we deploy this in a live environment, this model can be used on any new data which comes in. So the model can run on unseen data and predict the outcome. That's the beauty of the model building process. So this ways, as a business, you can leverage your strategies in terms of based on the outcomes. You can come up with different strategies in terms of either mitigating a risk or if you want to target specific customers and so on, you can use it for various different purposes. So this is the overall predictive model building process, which I summarize. So as we discussed, first we define the business objectives, and then we prepare the data and we analyze the data attributes and elements, and then we try to identify which is the best model for this particular scenario. We run this model and try to improvise this by fine-tuning the model based on the final metrics and based on the business objectives. Then we try to deploy the model in a live environment and kind of monitor whether the model is performing over time, and also document and keep the model audit trail for future purposes. So now that we have looked at the overall predictive modeling process, now let's look at the different types of predictive models. First, regression modeling. As we have seen in the past, regression model is where we are trying to establish a functional relationship between a set of explanatory or independent variables x1, x2 to xp with either the target, or we call it as response, or dependent variable y. So the equation for regression is y equal to the function of x1, x2 to xp. So here the knowledge of y is crucial for decision making, but it is not deterministic, whereas x is available at the time of decision making and it is related to y, or the target variable. So in summary, a functional relationship between y and x gives an idea about the otherwise non-deterministic y, which is the target variable. So let's see some examples. So if you run a leasing business, a customer has come to you and asked for funding on the lease. So as a business, the question which you have is, should we grant the customer the lease or not? So the information which is non-deterministic at this point in time is, you do not know whether the customer will default on his payment. What would be the maximum amount that we can approve? So these are some of the outcomes which you want to predict. Whereas the known information, which is the X, which is available to you, is you can get the information on the credit history of the customer. You can see the past transactions of the customer. You can try to understand the financial status of the customer. So using these information is where you can build your model. So a functional relationship between the target variable y and all the independent variables x helps in deciding whether to fund this particular leasing deal or not for the customer. So now let's understand the different variables or the features. So we call the x's as explanatory variables, because these are the independent variables which explains the target variable. So some of the different forms of the explanatory variable are, it could be either numerical, which could be a discrete variable where could be like number of products, where it takes discrete values like 0, 1, 2 or so on. Or it could be a continuous variable. For example, it could be an amount variable or credit limit, which can take any value from, let's say 0 to, let's say 500,000 or more. The other type of variables are categorical. The first one is ordinal. So ordinal variables are the ones by the name it can be ordered. Example, income group. Here you can order the income as low, medium or high. Next type of categorical variable are nominal. Here, example, it could be like gender, where it takes named values like male, female and so on. In terms of the target or the dependent variable, primarily, okay, it could be a continuous variable where it could be an amount figure like total dollar amount that we are trying to approve for this particular customer. Or it can be a discrete value where it can be like number of equipments that may be funded, which is 1, 2, or 3, which is a discrete number. Most of the other cases, you see that the outcome variable would be a binary variable, which we are trying to predict. So in this case, we are trying to see whether the customer is going to default on his payment or not. So it generally takes a value like 1 or a 0. So now let's look at some of the key aspects of linear regression. So in linear regression is where you see that the dependent or a response variable is always continuous in nature. And here only linear relationships can be modeled. So as you can see in the figure, the curve is a straight line between y and x which has been fitted. So it's a linear relationship which has been fitted for this particular equation. So the model for regression takes the form y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus an error term. So here the beta naught is the intercept term, which is when all your other independent variables are 0. So this is going to be the intercept term. And all your beta 1, beta 2, beta 3, they are the coefficients or slope of this particular line for various independent variables which would be used to predict y. So why do we have an error term? Is there in a model building process, there will always be some bit of uncertainty. So here, that is where, okay, there will be some errors which we are representing by the term E. So some examples for regression. You can have a dependent variable which is annual expenditure, and the independent variables could be, if you're trying to predict your annual expenditure, you can use the variables like annual income, family size, etc. to predict this. The second could be you want to determine the time to reach a particular destination. Here again, you can use different independent variables like speed, traffic, driver, or vehicle movement. Yeah. The next example could be, okay, you want to predict sales, and you can use variables like discount, advertising, and quality. Now let's look at logistic regression. So logistic regression enables us to seek and retain your most profitable customers. So we can use demographic data and customer buying patterns to develop lifelong relationships with customers to anticipate and fulfill their needs. The second use case for a logistic regression is if you want to segment your market for a targeted approach. So you can use it for target marketing campaigns to dramatically increase your response rate, to analyze the clickstream data, or if you want to sharpen your online e-commerce strategy. The next use case could be for if you want to predict the future and identify the factors to secure a particular desired outcome. For example, if you want to improve your production process quality by anticipating problems before they occur, like which machinery will fail, or you want to forecast your resource demand, or you want to increase the acquisition of a customer, and you want to assess the risk of a customer credit application, whether to approve a particular credit application or not. So these are the various use cases where you can use logistic regression. Remember, like we discussed, in linear regression, the outcome variable is continuous in nature, and the predictor variables can be a mix of numeric and categorical. But most of the situations, like we have seen, we would have like a binary outcome variable which we are trying to evaluate. So in this case, either you're trying to predict whether a customer will default or not. So it's a binary outcome which you are trying to predict. So whenever you have an outcome or a dependent variable which is binary, and we want to measure the effects of several independent variables on this, then we use a logistic regression. The curve which is used is a logistic curve. It's an S-shaped curve, as you can see on the figure. So here again you're trying to predict your target variable, which is a probability of an event happening or not, and you're using various independent variables, which is your X variables. So the binary outcome variable, you can code it as 0 or a 1. So 0 is for failure and 1 for success. So the logistic regression equation is P is equal to exponential of a plus bx divided by 1 plus e to the power of a plus bx. So now we are going to look at some real life use cases for predictive modeling. So let's look at two examples in a live scenario. First is you want to predict the customer churn given there are certain attributes like demographic information, you got credit history, you got your account information, etc. So given here, it's going to be a binary outcome. Like we discussed, we will use a logistic regression live example to walk you through how you can build this model. The other example we will see is to predict the grade of a university student, whether he has passed or a failed, based on some basic student data which is available using linear regression and also logistic regression. For the first business case, which is predicting churn. So what is the business objective? So here the background is that a banking company wants to reduce the customer's churn by identifying the customers who are likely to churn in the near future. So by proactively targeting these customers with retention offers or personalized services, the company can aim to improve customer retention and reduce the revenue loss. So what kind of variables or information data which you have? Yeah. So we can get the demographic information of the customer. We can get a lot of account level information like balance, number of products, okay, and so on. You can also get a lot of financial information like what is his credit score, right? So worldwide, okay, you got like FICO score, and in India, you see, you got like a CIBIL score, yeah. Similarly, you can try to have his information like what is the balance and currently he has on his account. Does he have a credit card or not? Okay, yeah. And also you can look at like customer interactions, which is how active is the customer, and so on. So now before we get into the live model development process, so just again a quick recap of how a model development is generally done in an iterative fashion. So first is, okay, we identify which are our explanatory, which are the x variables, and which is our target or the response variable. Then depending on the model outcome, we try to decide on the type of the model. Is it a logistic model or is it going to be a ordinary least square regression linear model? Then in terms of feature selection, like I discussed, can do the initial correlation analysis, okay, identify which variables are going to be predictive, yeah. And then what you can do is either use different methods like, okay, like stepwise, where you try to add in each and every features or variable one by one, right, and try to see how the model's predictive power is increasing, yeah. And you can iteratively, okay, add or drop variables depending on the model evaluation metrics. So while you are selecting the models and when you're training the model, okay, part of your model development phase, yeah, you should also look at different factors where if there are multiple variables, okay, some of them can be correlated to each other, not just with the dependent variable. So in these cases, there are metrics like variance inflation factor. You can check those for a threshold value to check if there is any multi-collinearity which is involved. So when you're running the model, depending on, okay, are you running an OLS or a logistic, right, okay, you can evaluate the model, okay, based on various parameters. And once the model is run through, okay, it's going to be an iterative process where you try to run the model, okay, you either drop or keep a variable, right? You iteratively, okay, either transform some of the variables, okay, and then try to run the model. So once you have reached like a balanced model where you feel that, okay, the model is able to predict uh, the best true positives, etc., right? Or the accuracy rate of the model is good. So once you're comfortable with your model evaluation metrics, you can get approval from your business stakeholders. So this is the case where, okay, whenever I used to go for a lot of client meetings, okay, across Asia Pacific, we used to have like one dedicated session where we used to have all the business stakeholders where we'll run the model and show it live to them. And what we will do is, okay, based on their inputs, okay, either we'll try to include any additional variables, okay, which they feel it's more important from a business perspective, or we may try to remove some of the variables which they may feel, okay, like maybe they may not be appropriate and so on, and kind of finalize the model. Yeah, once we have finalized the model, okay, now we can deploy the model in a live environment, okay, and the proof lies in the pudding. That is where, okay, the model should be used for a business purpose for which it was intended for. And you should also have effective documentation in terms of how the model was developed, and you should have all the audit trails in terms of how different variables were, okay, included or decreased, right? So that, okay, it could be leveraged for any future audit or any regulatory purpose. And then while developing a model, you can keep some of these, okay, like checklists in mind. First, like we discussed, okay, first we should define what are our dependent or target variable, right? And which are our independent or predictor variables, yeah. And then we need to, okay, process our data and create an analytic data set. So prior to creating an analytic data set, we can apply some exclusion criteria based on business logic. For example, if you are trying to, okay, like create a loan data set, okay, but if you have customers who are underage, less than 18, so they would be like policy exclusions, and so that ways you can apply some exclusion criteria to remove them from your modeling data set. And like we discussed, you can divide your model into development sample and validation sample. The general thumb rule is, right, okay, you try to build your model on your 70% of your data and 30% you use for validation. And during the model development process, like we mentioned, the feature or variable selection is very key. You look at some of the statistical metrics like p-value, etc., to check on the statistical significance of this particular feature. Yeah, and only if it is statistically significant based on your threshold, you can retain them. If you want to drop them, right, okay, you can remove some of those variables and add any other additional variable. And we could also, okay, like we discussed, run couple of different models, right, okay, and then you can kind of evaluate, okay, the various models, right. Some of the key parameters, okay, in terms of primarily when we have looked at for logistic regression, etc., is how the model is able to rank order the customers in some of the initial deciles, okay, when we are plotting it. So what we are trying to see is the model able to differentiate between the good customers and the bad customers, okay, in a much more effective way, at least even at the initial levels of the scores and so on. The other metrics you can look at is, yeah, like we discussed, you can do an in-sample model validation, right? You rerun the model and check whether, okay, some of the parameters are they still stable, right? Okay, and you can score the model and compare its outcome. In many cases, from a regulatory and other perspective, we also do a lot of out-of-sample model validation. So here what we do is you run a model on a particular time period of data, and then you do an out-of-sample validation of this model on a new time period of data or a recent most time period to check whether the model is still effective, okay, even during this particular period. And also another very important model monitoring or a model evaluation metric is you can compare the predicted versus actual values. As you all know, models are generally, okay, based on historical data. You run a model with an assumption that your past is going to represent your future, which is your business conditions are going to remain the same. Yeah? If in any case you feel that, okay, you're going to have like a totally new business environment and so on, if there is going to be a lot of changes, then in many cases your model which was built on a previous business environment cannot work always. So that is where, okay, you can test your model, okay, based on for a particular data, you might have an actual value of, okay, let's say whether a customer has churned or not. Now you can run this model on a new data and check whether, okay, what is the predicted value and, okay, what is the actual value we are able to track based on, okay, like customers churn maybe after some period of time. And you can kind of check the effectiveness of the model. So now that, okay, I've kind of given you a background in terms of what we have looked at in our previous videos with respect to the overall predictive model development process. Now let's come to an interesting aspect where we can do a live model development, okay, using an Excel plugin. So here I've used Excel so that, okay, because Excel is very powerful for you to understand the basics and you can play around with it, okay, and understand some of the fundamentals. But there are various model development tools which are available in the market, right? Okay, depending on your organization and, okay, where you have your license, etc. You can use softwares like SAS, you've got FICO's model builder, or you can use open source softwares like R or Python, etc. Yeah. Whereas for our current purpose, we will use an Excel plugin which was developed for, okay, one of the universities for teaching purpose. So it's called Regress IT. You can download this plugin online. Okay, it's free to use, and you can play around with it for your learning purpose. Now, are you all ready to dive into the live use case? I'm going to open an Excel. Yeah. So this is our first use case, like we discussed. So here we got the various variables or features to predict, okay, whether a customer is going to churn or not. Yeah. So as you see, so you got the customer ID, which is an identification variable. Yeah, it's not a predictor variable, but this is what identifies, okay, your customer. So then we got credit score. As you all know, credit score generally ranges between 300 to 800 and so on. The lower the score, there is a higher probability that the customer may not perform well, and the higher the score is better. And most of you would have noticed that, okay, like whenever you go and apply for your loan, etc., right, okay, at the back end, the bank gets your CIBIL score, right? So how do they get it? Is CIBIL is a credit bureau, right? And they get all the information from various banks wherever you might have an account relationship, and they would be tracking in terms of, okay, your performance, and they quantify it based on a score. So higher the score, better is your probability to secure a loan. So then there are various other columns like, okay, you got like the geography of the customer, you got the gender, which takes values like female or male, and then age is a continuous value, right? Okay, because many times if you see some of the young age customers, okay, they've just joined job and so on, whereas there are people who are, okay, well settled in their job during their middle age and others, right? Okay, and then similarly, okay, if someone is closer to a retiring age, right? Okay, then maybe they may not have that proper cash flows and so on. So a lot of features, a lot of the banks and organizations look at. Yeah. And then the tenure in terms of how much time you are with the organization or with the bank. Yeah. So I think that also gives a good factor. And then you got the balance information, okay, in terms of how much balance you have in your account and the number of products you have. Okay, the more sometimes number of products you have, which means you got a very good relationship with this particular bank or organization, right? Okay, that means your probability of sticking with this particular bank would be higher. Yeah, and a lot of these are just hypotheses. This is where we'll use live data to check, okay, whether they are true or not, and okay, the model is going to pick that up. And sometimes, okay, whether you have a credit card or not, okay, also kinds of gives you a lot of other information, right? Okay, and these are like, okay, some of the customer usage metrics, which is, are you an active member or not? Sometimes if you are not an active member, which means you are not engaged well, right? And then what is your estimated salary, right? Okay, and then in this case, given this was like a sample data, or in many cases, okay, you'll have your actual predictor information available. So that is your target variable. Here exited is your target variable. It takes values as 1, 0, and so on. Yeah. So now let's dive into this data. So you have this Regress IT plugin. In this plugin, if you see, it gives me a lot of these ribbons like descriptive statistics, linear regression, logistic regression, and so on. And you also got an instruction manual, etc., which you can play around. So if not, you can also use it with your normal Excel. Excel has its own features where you can do a lot of data analysis and you can run regression. Yeah. So here you select your data which you want to model. Yeah. First, you create names, or you find which is the header variable or the column names which you want to leverage while you're preparing this data set. So here I've selected the top row. Yeah, so once I've done this, so now it's picked up those header names and others. So now we can run some descriptive statistics. Yeah, so in this case, so here it opens me a drop box. Yeah, so here I can name the statistics, whichever name I want to give. In this case, if you want to select all variables, I'm selecting all. Maybe customer ID and row numbers are just there for more for identification, so I've just removed them. Yeah. You can choose, there are various options. If you want to select some time series statistics, you can do that. You want to identify the distribution statistics, yeah, and series plots, right? So, and even scatter plots, if you're running like a linear regression, you want to identify the relationship between, couple of variables, you can do that. In my case, I want to have an histogram plot, right? And then, yeah, so now let's go, hit the run button. So it's running, it's going to give you the descriptive statistics. So in this case, yeah, so there was an error, but it has thrown us the output. So if you see here, so you got all these different variables, which we already had, So for example, age. So we know, what is the mean value of age in this data? So it's around like 38. And what is the median value, right? What is the standard deviation? What is the minimum value and maximum? See, sometimes, right? You can't have age above 100 and so on, which means there is some error in the data. So those are the ones we're calling as outliers, where, you can treat that data and, either cap it to the maximum value, which you feel is within your business considerations, or you can even delete those records. Yeah. So similarly, like I mentioned, credit score generally runs between, like 300 to 900. Yeah. So you can check whether it is within those parameters. Yeah. And see, your target variable, can take only two values, which is 0 or a 1. Yeah. And similarly, your number of products, it could be only here it is 1 to 4. So in this way, you know whether your data is right or wrong. So you run this. In my earlier case, yeah, I've run it. You can also get like the correlation matrix. So for example, what is the correlation between balance and age? And this particular plugin also, if you select colors and fonts, right? It can also give you, which are the ones which are positively correlated, which are the ones, which are negatively correlated, and so on. Yeah. So in this case, if you see between the target variable exited and age, there is a very good positive correlation of 0.288. And similarly, whether you are an active member or not, there is a good negative correlation. That means if someone is active, his probability of exiting or churning will be lesser. Whereas if he is not active, that probability is going to decrease. So now that we have done this, now let's see, how we can run a model. Yeah. So I'm going to again go to the data, right? I'm going to select the data, create names, right? And then let's choose logistic regression. Yeah. So in this case, I'm going to see, I've run a model, I'm going to show you an output. Yeah. So this is how, when you choose logistic regression, and then you choose exited as your variable and then you run it. This is how you're going to get your output. Yeah. So in this output, you see that, like this equation, you got the predicted probability, right? And then you got like the final output, which is the log odds is, so there is an intercept or a constant value, plus there is a coefficient. These are the beta 1s and beta 2s, which we saw in the equation. For age, there is a coefficient of 0.075, which is identified by the model. And similarly for other variables. So now let's look at, some of the colors and fonts here. So we see age is coming to be a very good predictor variable, right? Okay, and it is also a significant value. Okay, so what you can also do is, okay, you can also look at for your p values, right? Okay, if some of them are very high, above like zero point 0.2 or 0.3, right? Okay, if you want to drop them, okay, you can even drop them. Yeah, so what you can do is, okay, you can select some of it, part of this plugin, okay, you can remove some of them. Yeah, so this is where, okay, model building is also an art where you iterate and, okay, run this, right? Okay, so here is where, okay, you were able to run the model. Yeah, and then if you see here, this is the classification matrix which we are talking about. Yeah, so here is where you are able to see that I'm zooming this. Yeah, so in the original data we had like the number of no's or zeros we had, and the numbers which were rightly predicted is around 2576, right? So here if you want to increase our true positive rate, right, okay, you can play around with either decreasing, okay, some of your cutoff values, right? Okay, or if you want to increase, so that, okay, you want to get the accuracy right. Okay, so you can play around with it. Okay, so for me, I'm comfortable with, okay, like let's say a cutoff value of 0.25, right? The true positive rate is like 60%, which means we are able to identify, okay, most of the S's in the original model, around 60%, the model is able to identify. And the overall accuracy of identifying not just the S, but also the nose is around 72%. So here is where, depending on, like we saw, depending on if your criteria is that, okay, you want to have a better true positive rate, okay, then you can play around with the cutoff value, okay, and then get the right model. Yeah, and the ROC curve, like I mentioned, okay, which is one of the most powerful visualization, right? Okay, here it is between true positive rate and your false positive rate. So you got the curve. So what this means is, okay, so you divided the entire sample into 20% categories, right? Okay, so the more we are able to identify, right? Okay, some of the, okay, the positives, right? Okay, in the initial category, or in some cases if you're predicting a bad, if you are able to differentiate between your bads and goods, so your bad rate percentage, okay, if you are able to differentiate them in your lower deciles, I think that is like the best model, right? Okay, so in this case, okay, so again, okay, we can play around with the cutoff to see where are we able to identify the best true positive rate. Yeah. So in this ROC curve, as you see, the line on the diagonal, okay, which is like a no model, which means when I go here, I'll be able to identify exactly only 20% of bads versus 20% of goods. Whereas if you see in our model, yeah, I'm able to identify around, okay, close to 50 to 60% of, okay, the bads are, okay, which I'm able to identify, okay, and then I'm able to differentiate between, okay, between my true positive rate and false positive rate. So that's the power and beauty of the model, right? And here part of the logistic curve plot is where, so this is one example where, okay, for your target variable and age, okay, it's showing like a very good S curve where the we are able to identify that, okay, with increase in age, okay, how does uh, okay, the customer react in terms of, okay, whether he exits or not. Yeah, so you can play around with this across, okay, different variables and so on. And there is also one more very good outcome chart here. So here again, okay, you are able to find the distribution of the outcomes, right, across your zeros and ones, right? And the more you are able to see a difference between, okay, for example, in this first category, okay, we are able to identify more number of no's compared to s's, right? Okay, similarly, okay, in the initial okay, categories, we are able to identify again more number of no's. I think that means the model is able to clearly differentiate between the s's and no's. So once you feel comfortable, okay, you can run these models in terms of various iterations, right? Okay, so in our cases, right? Okay, yeah, you can run this model across different iterations, yeah, and you can see the different coefficients and so on. Okay, you can drop some variables and yeah, and then see which is your final best model. Okay, and once that gets approved with your stakeholder, then that is the model which you can finalize. Now that we have seen one case for logistic regression, let's take a simple case where, okay, I can show you both linear and logistic regression. Yeah. Given many of your early learners and students, right, okay, I thought I've taken a general data information, okay, which is available online to predict, okay, the grade of a particular student in a university, right? Okay, so this grade variable takes only zeros or ones, right? Okay, and it has got a lot of other explanatory variables like what is his overall CGPA, okay, how much is his score, and okay, the economics, okay, how much is his, okay, the other inputs which are given by the teachers, etc., okay, which is captured part of PSI. Yeah. So here I've already run a linear model. Okay, so you can go choose similarly. Okay, select data, do descriptive statistics. Okay, and then you can choose a linear regression model. Yeah, yeah. So if you see here, yeah, you can choose. Okay, what is going to be your dependent variable? So here we have chosen grade. Okay, we chosen the other independent variables. Yeah, and then you can choose. Okay, what are all the plots which you want to look at? Right? Yeah. Uh, and uh, and then yeah, so for I'm choosing a line fit plot and standard residual plots, right? Okay, so here, okay, I'm just going to run the model. Yeah, so as you see here, okay, now the model is run. You can expand this. I'm just going to zoom this for you. Yeah, so you can see it's a very simple and powerful equation. Okay, so the predicted grade is nothing but a constant value plus, okay, 0.464 into the GPA value plus 0.379, okay, into PSI plus 0.01 into their economic score. Yeah. And like we saw in model evaluation, you can look at the R square values, right? And then, okay, you can look at the adjusted R square. Similarly, okay, you can look at, okay, the T statistic and the P values, okay, like we discussed. And if you feel some of the variables, okay, are not looking significant, okay, if their P values are very high, then, okay, you can drop those variables, yeah, and rerun the model, yeah. And here again, okay, you can see, okay, through different charts, etc., right, okay, you can see what is the difference between the residual value and your predicted value, right, okay, and you can get like an histogram and so on. Yeah. So this is how, right, okay, you can run a linear regression model, right, okay, so which is nothing but, okay, y equal to a plus bx and so on. Yeah. So learners, what we have seen is two very good powerful examples where, okay, I walk you through a live example of both regression and also we saw for logistic regression as well. Okay, so I've used simple Excel, okay, so that you all can also, okay, recreate these, okay, and then learn these concepts. You get a lot of data sets online. Okay, you got like Kaggle where, okay, they run a lot of different competitions for data analytics. Okay, so you get a lot of sample data sets. Okay, you can pick up a business use case depending on the predictor variables. Okay, you can run these models and try it out for yourself. Thank you for watching this video.